First, I would like to congratulate China and the Chinese research community to the beautiful ship Challange 2. I really look forward to increased collaboration, for example, in the Arctic Ocean to meet the challenges. It's a beautiful ship. Congratulations. So, the Swedish Polar Research Secretariat, a few words about us. We are a government agency mandated to coordinate and promote Swedish polar research. We organize and support Swedish research expeditions to the polar regions, and we also manage research infrastructure. The Secretariat's mission and activities comprise advance high-quality polar research and the dissemination and use of research findings in the society. We perform research planning together with the research community at the universities in Sweden and worldwide. We manage research infrastructure, communication, in international negotiations and partnerships. We represent Sweden in polar matters and dispense permits according to the Swedish Antarctic Act. The infrastructure that we manage is the Abisko Research Station in the high Swedish mountains. The Vasa and Svea research stations on Antarctica, Dronningmordland, and the icebreaker Oden. The icebreaker Oden is one of the world's most powerful icebreakers. It's adapted for research. It wasn't built for research from the beginning. The icebreaker Oden is also an example of Swedish innovation. It's 30 years old, still regarded as innovative because it has a special way of breaking ice. As you can see, it does not look like an ordinary ship. It has a very broad front. In ice-breaking mode, it splashes the sea ice in front of it with huge pumps, and in that way lubricates the ice, enter up on the ice, and then smashes the ice with its own weight. It has also access to a healing system where it leans from port side to starboard side in order to perform a broad channel after it, which makes it possible and convenient for other ships to follow. However, we are now facing new challenges that we have heard about so much during yesterday and today. We have lack of data, especially winter data, and we also have lack of ships who can perform winter expeditions to the high Arctic Ocean. And we also have lack of coordination of those ships. There are good examples of international collaborations. The ARISE EU-funded project is one example, the Synoptic Arctic Survey is another, and the Mosaic expedition that Marcus Rex will present in this session later are very much talked about international good examples of collaboration where also China and Sweden collaborate. So, but it's a fact that it's time to talk about next generation of icebreakers for polar research. And I would like to emphasize that this is our forward thinking. We are not yet mandated to build this beautiful ship here, but I would like to share with you some visions for a future sustainable Arctic icebreaker. We, the scientist community, we are studying the climate system, and we all talk about sustainability. And therefore, ice-breaking research vessels should be climate neutral. We want to limit our environmental footprint. The ship could also, via public-private partnership, be used for many various missions in the society. Of course, for research expeditions during summer and winters, it could have a modular system where you can put on labs and take off the labs. And also the ship could be used for sustainable tourism. So, to build a sustainable icebreaker, it's of course complex. Sustainable development is complex, and no part alone owns the solution. In Sweden, the triple helix model is the model of innovation for Agenda 2030. And the triple helix is the academy, that is the research society, together with industry and together with governments, and they join together in the triple helix model of innovation. So the challenge that we are in front of is that a sustainable solution for what is the sustainable solution for an ice-breaking research vessel? We have gathered perspectives from the polar research community, and of course we say it should be climate neutral or have the potential to become climate neutral in the near future. No black carbon. It should be all the beautiful equipment that we heard about from Challange with the launch and release systems for ROV, etc., etc. I just admire your ship, I must say. From the industry's perspective, it must be a scalable technique. There must be a business opportunity. From the government, we have requirements that it should fulfill the Agenda 2030 and preferably be fossil-free fuel. In Sweden, we have a climate law saying that we should be climate neutral in 2045. So, the question for Arctic fuels. So what is a sustainable solution? Well, a sustainable solution should be transformative, holistic, and scalable. Transformative in this situation means that it should lead to a change in fuel use, transforming the business by using better technology. It should be holistic according to all the 17 goals in Agenda 2030 in a system perspective, taking into consideration the whole impact of the fuel, production, transportation, and also impact on society. It should be scalable, can be applied widely reach scale where it makes an impact. So we went to the industry with the question, methanol or methane? If you're not a chemist, I can explain. CH4, that's methane, and the other chemical formula, it's methanol. So we asked the Swedish industry in the triple helix model, what fuel selection for which is the best fuel selection for new icebreaker? Is it LNG or methanol? This is the result of the case study that Stena has presented. Well, they first, as a shipbuilders with the operational profile, that's the start. There is a difference between operating profiles compared to ships and carrying cargoes and icebreakers. Significant time is spent in idle for an icebreaker, and during idle, LNG fuel has to boil off. And icebreaking entails rapid load changes on engines when operating, ramming, full forward and full astern. And LNG is very good at steady state operations, but LNG has challenges in rapid response to increased throttling. Methanol is a liquid fuel and it acts well during rapid load changes. Further considerations. Both methanol and LNG are non-pollutant if spilled into the sea, so that's equal. But methanol requires twice the volume as LNG on board to carry the same energy, but methanol can be carried in conventional tanks, whereas LNG special tanks takes up a large volume. Methanol is non-pollutant according to MARPOL and can be carried in the outer hull. And according to the shipping industry, this gives flexibility for icebreakers design. Further considerations, for new buildings, the LNG propulsion is about twice the price compared to methanol. So there is a huge change in the economy here. From the local environmental perspective, black carbon is a problem if you use diesel, for example. Both LNG and ethanol contains only one carbon atom and does not produce black carbon or soot. But when it comes to the greenhouse gases, About 1% of the methane in LNG slips through engine without combustion. And we should consider that methane is one of the greenhouse gases that is at least 25 times more potent greenhouse gas than CO2. Methanol, on the other hand, is transformative. The production of methanol is nowadays limited. It could start its start is industrial production from natural gas, but methanol can over time be produced from many non-fossil fuel sources, and we have started such demonstration projects in Sweden. So, adding up, LNG versus methanol. In this case study done by the Swedish shipping industry, you can see that we have 4 positive points and 4 negative points for LNG. That is plus minus 0. For methanol, in this case study, we have 7 positive points and 2 negative points. That adds up plus 5 for methanol. So the conclusion, for icebreaking LNG tankers, LNG is the obvious fuel. For new icebreakers, for Arctic navigation, methanol is likely a better option. So I'm looking forward to discuss this subject with those who are interested. Thank you very much, Nolan.